All right. Hello, everyone. Welcome back to Comp 2160 Programming Practices. I hope that you are all doing okay today. It's kind of a weird feeling for me to see you like every day, but it's also kind of cool to just see you every day. I don't know, that makes me feel good to see you all. There's like some consistency in my life and not just students sometimes and every once in a while. I'm also feeling good today. Well, I don't know if you've been outside, but like it's sunny, things are starting to look green. It's still windy, but I will deal with that. I'll accept that. I'll accept windy. It's sunny and green. It's starting to warm up. It's starting to feel like summer, and I'm really happy about that. Today, what I want us to be able to do is I want to continue working on this learning outcome, build and execute programs from a command line environment. We've kind of done this already. We've compiled a C program on the command line, but we have not compiled a Java program on the command line. And part of this might be, well, what do I care? What do I care? This is not a C course. It's also not a Java course. Our first exercise that we're going to be doing for an assessment involves translating a Java program into a C program. And so knowing how the Java program behaves, what it does, how it works, when it's run on the command line is an important part of being able to reproduce that in a C program. So by the end of today, you should be able to do both of these things, compile and run C programs and compile and run Java programs on the command line. I want you to be able to write a simple C program. This is not a C programming course, but we're going to spend time today talking about the C programming language. The specific context that we're going to be doing this in is I want to look at an existing program that's written in Java, and I want to translate it into a C program that does the same thing. I want them to be functionally equivalent to each other. And we're going to step through the process of doing that. And while we're stepping through the process of doing that, I want to make sure that we're comparing idioms in each of these languages. So what does it look like in Java? How do I translate that into something that's meaningfully the same in C, even if it isn't exactly the same as it is in Java? I want you to start this. I want you to be able to recognize potentially risky programming techniques and how they differ in different high-level programming languages. We're going to start looking at this. This is going to be a long-term ongoing thing. We'll start looking at it today really specifically, really specifically in the context of exceptions in Java. This is going to be kind of related to this, and it's going to be the way that we're going to approach a lot of this stuff is we're going to begin to compare and contrast C and Java. So we'll start with a Java program. We're going to try to recreate that Java program in C. While we're doing that, we're going to be adding a bunch of commentary on it. And then after that, we're going to formalize it. So I've got some slides that are formalizing these differences so that you have a reference of what I'm doing as we're writing this code. But before we get to that, I want to finish this exit slip exercise that I started with you on Monday's class. I'm sorry that I didn't get to it yesterday. My poor time management skills led to us not being able to get to it. But I think it's important to hear from you what you want and why you think that we're doing certain things in this course. So one of the first questions that I asked you was, what do you want to get out of this course? What's the main thing that you want to get out of this course? One of the answers that I got was a good grade. And I got that a lot of times. Lots of people want to get good grades in this course. And I will do my best to help you get that good grade. I can't just give you a good grade. I will help you get to that good grade point, but I hope that we can all get to that good grade point. The other thing that people want to learn is a new programming language. And lots of people want to learn new programming languages. This is not a C programming course, but we're going to learn C in this course. So you will learn, hopefully, one new programming language by the time you're finished. You're actually going to sort of start to learn another language too. When we're doing stuff on the command line with our shell, the shell is also a programming environment. You can write loops, you can write conditional statements, you can write functions, you can do all sorts of weird stuff with your shell in the command line. Probably shouldn't, but you can. And so you might start to see another language there. And so you might come out of this course with like 1.2 new languages instead of just one. But you're definitely going to learn one new language. Learning a new environment was also something that was pretty popular. I'm kind of guessing that most people, that even if you had a terminal on your machine before, you weren't using it too much. And that's okay. That's totally okay. There's no reason for you to need to use this in a course like Comp 1020. We're going to be learning a new environment. We will do this. We'll take a look at Linux throughout the term, and we'll be looking at the command line. Again, lots of people wanted to be able to do this. Debugging strategies was something that came up a lot. I believe that you have at least seen a debugger in 1020. Yes? Yes? No? 2 people did. Good. Okay, so those 2 people know how debugging works. Good. Everybody put their thumbs up. I'm confident that you all saw debugging in 1020. You all saw how to do debugging with VS Code and Java in 1020. We're going to look at strategies for debugging, and we're also going to look at using command line tools for debugging. So Java and VS Code are kind of tightly integrated as this nice visual debugging environment, but that's not the only way that you can debug things. And in the context of C programs on a remote computer, sometimes the only way that you can debug them is on the command line. So when you're sending stuff over to Aviary, Aviary is not the same as your laptop. So something that works on your laptop may not work correctly on Aviary, and so you'll have to do debugging on Aviary at some point, probably during this term. And so we'll take a look at how to use command line debuggers, and we will take a look at some debugging strategies in the course. Lots of people wanted to learn how to write efficient code. We will talk a little bit about this. We'll talk a little bit about performance closer to the end of the course. Although the performance that we're looking at in the context of this course is making the right choice of data structures more than like dropping down to assembly language to make things just go faster. The other thing that I asked you was why would we choose C for a course like this? So you've learned Python or processing, you've learned Java, and now we're starting to learn C. And I'm wondering what you think about why we're learning C. One common answer that I saw is that C is faster. How many people, just quick thumbs up, how many people think that C is faster than Java? Okay. How many people think that C is slower than Java? One person. Okay, thanks. Do you know what you're agreeing to right now? No idea? Okay. How many people think it's about the same? In some cases, it's about the same. Java and C and Python, they do have very different performance characteristics. Python as a programming language is kind of at least famous in my mind, if it's not famous in the bigger, wider world. It's famous in my mind for having a bunch of libraries that are written in Python with implementations in C. So if you took Comp 1012, you did NumPy a lot. NumPy is almost exclusively written in C with Python integration. You can call these functions from your Python program. Java is kind of this like in-between language. And Java is this language where the biggest cost for a Java program is starting the JVM up. Once the JVM is running, so you type Java or you click the run button, once it's running, Java code executes pretty fast. It executes pretty fast. But it takes such a long time to start the JVM that it looks like it takes way longer for a program to finish. Java and C are comparable in certain circumstances in terms of their performance. C gives you direct access to memory. 100% yes. And then this is a lie that will be told to you in 3430 in operating systems that it's not actually true. But for now, for what we're talking about in this course, yes, 100% true. C is going to give us direct access to memory. With Java and Python, we wrote code. We didn't have to think a huge amount about what was going on in the background. We didn't have to know about how our hardware works. We just kind of wrote our code, clicked the run button, and things happened for us. With C, we're going to have a little bit closer access to memory. We're also just going to have a little bit closer access to hardware. We'll be able to interact. We in this course will not interact with, but you would be able to interact with hardware devices that are attached to the system a little bit more easily in C than you could with Java. And that relates to this point. It's lower level than Java or Python. The JVM that's made by Oracle is primarily written in C. The Python implementation, the standard Python implementation, is primarily written in C. You got to start with some language at the bottom before you can move your way up, and C is definitely that language. This also came up a couple times. It's one of the most commonly used in industry languages. And so I put a link here. This is to a website that's called the Tyobe Index. And what this website does is lists what are the most popular programming languages in the world that they have measured somehow. I don't know how they measure this, but this is what they claim. Python is the most popular programming language right now in the way that they measure the popularity of programming languages. C is next, C++ is after that, Java is after that. So sure, C is actually a pretty popular programming language out there in the wild. I don't know how they measure this. It might be completely inaccurate, so take that for what it's worth. Before we get to taking a look at our assignments, I did want to pick out some of these that I liked the best. So why did we pick C? And favoritism in basic languages. I guess this is my favorite language. And a good grade. I like this one a lot. So this one says, I think we are using C as it doesn't contain many safety features built into it, like Java and Python. We're going to look today at some code, and the code today is going to have exceptions in Java. And I don't mean to spoil it, but there are no exceptions in C. No exceptions in C. We don't have that feature at all. Spoiler alert. Let me pick another one here. I like this one as well. We choose C because it is hard to learn. So it teaches us to adapt to hard languages. Yeah, sure, maybe a little bit. Like I said last time, that book that I brought, the C programming language, it's really small. C is a simple programming language. C is a simple programming language, and kind of related to C doesn't have the same kinds of safety features that other programming languages do. I'm going to say that C has what I would like to call foot guns in it. A programming language like, okay, so this is another English idiom. I can't stand seeing myself in the corner here. This is another English idiom. The English idiom is to shoot yourself in the foot. Do you know what that means? Does everybody have an idea what that means? Okay. Kind of like you hurt yourself in your confusion. You do something and it just kind of goes wrong because of that. Programming languages like Java and Python will help make sure that the gun is locked in a gun safe correctly so that you can't access it if you don't need it. And a programming language like C helps you aim the gun at your foot. That's what I like to think about these languages. They take a lot of that safety stuff away. So thank you all for sharing this. Thank you for giving me your input. I hope that we are able to get to where you want to be in this course by the time that we are done. And I hope that by the end of the course, you're able to see why we've selected C. A lot of it is because it is not a harder programming language to learn, but because it takes away a lot of the safety features, and it kind of gives us the ability to demonstrate a lot of the better programming practices that we're going to be looking at throughout the course. So thank you all for that. With that, I would like to take a look at two things. I'd like to take a look at assignment 0 and assignment 1. So on the course webpage, in the content section, there is an assignments section. The assignment section has 3 things in it right now, 3 sections. The first one is called resources. There are 2 documents here, programming standards and best practices. You should read these 2 documents. You may have seen things like this before in Comp 1020 or Comp 1010. These are specific to this course, and these are the things that are going to be used in the assessments for you in this course. The programming standards is a document that describes the basic things that you should or must include in your document, in your source code. So things like comments that describe who you are, comments that describe what your functions and methods do, the use of blank lines, printing things, names of variables, brace locations, that sort of thing. The best practices document has some of the same things in it in terms of what's going on, in terms of what you should be doing, but it's a little bit more comprehensive in what it's doing to describe things to you. The one that I want to really point out here, really specifically, is I'm going to go down and down and down to this exit points part. This is one that I find lots of students get caught up with when we're looking at the programming standards and best practices in the submissions that are being made for assessment for assignments. The use of break and continue. So just by a show of hands, how many people know what break is? Okay. Show of hands, you've used this in a switch statement before. Okay, show of hands, you've used this in a while loop before. You've used this in a for loop before. Okay. In this course, switch is the only place that you should use a break. Switch is the only place that you should use a break. The advice here comes from, I'm going to straight up say it, people older than me. The advice is coming from people older than me. Old people. They're old people. They are old people. The advice is coming from people older than me, and it's really specifically about this idea of something that's called a go-to. Quick show of hands. Who knows what a go-to is? Just a few people. In the days before we had functions and in the days before we had methods, there were no functions and methods. It was just like a big blob of code. And the way that you would move around in your big blob of code was to label it. So it's kind of like proto-functions, beginning to be functions, but not quite. You'd have a label in your code, and then you'd say, go to that label. But there would be no like braces around anything. There'd be no structure in this code. You could just go to a label, or you could kind of go to a line. And you could just do it anywhere you wanted. And the whole idea of a call stack is up to you to figure out how to manage all that stuff. Break is kind of like, I want to go to the end of something. I want to exit this loop early. And it kind of goes back to that idea of, I'm just going to get out of the thing that I'm in right now and continue processing or continue executing code. I'm going to say, not because I'm an old person, but because I think this is a good idea, break in a context like this means that you've chosen the wrong kind of loop to represent something. So you want to repeat execution, and a lot of places where you're going to see this is if you're looping over arrays or if you're looping over strings. A for loop is a loop structure that it is designed to apply an operation to every element in a sequence. You don't stop halfway through. You're doing this thing to everything. So you're computing a sum. I want to take the sum of all of the things in this list. I'm not going to stop halfway through. I just want to compute the sum of everything. I want to copy an array from one place to another. I will copy the entire array from one place to another without stopping. A while loop is a loop that you use when there's an event that's going to stop execution. Sometimes the event is I is greater than some limit. Sometimes it's that. But more often it's going to be like, I found a thing in a list. So if I find a thing in a list, then it's the time to exit. But the way that I should be testing that is in the loop expression itself. So if I'm iterating over a loop and I'm trying to find something, I will use a while loop instead of a for loop. There are places where the event has happened before I finish processing. I know that I get this like I++ for free with a for loop, and I have to do it by typing it out. I got to type it out in both cases anyway. But with an event-based loop, there's a termination event. I will use a while loop. If I want to apply the same block of code to all elements in a list or sequence, regardless of what's going on, I will choose a for loop. So please make sure you're being aware of that as you're going through and writing loops in this course. Yes?
So say for a linear search algorithm, right, you're iterating through I to either the end of the file or you find something, you're saying to use a while loop for that and then just manually update writing what subs in the loop?
Yes. So confirming what you just said, if we're doing a linear search, either through a file or through an array, I would be using a while loop to do that. A linear search is I found something, that's the event, I found the thing I'm looking for, or I've gone past the end of the array. That's the event that I'm looking for in this case, as opposed to a loop that's going to iterate potentially over everything and then break out early if I have found that thing. Any other questions about that? We're good? We're all good? Okay. Okay, so there's lots more in here. Please take the time to take a look at this before you start writing code for this course. A lot of this stuff is relevant even to the Java code that you're writing right now. The other two things that are in the assignment section right now are assignment 0 and assignment 1. I'm going to quickly look at assignment 0 here. Assignment 0 is not for points. It's not for assessment. The only thing that assignment 0 here is for is to give you a chance to try doing stuff. You should be able to do assignment 0 right now before we started talking about anything today about C programming. Assignment 0 is entirely about downloading a Java program, transferring it to Aviary. Okay, so give me a couple more minutes and I'll show you how to compile a Java program on the command line. But you will be able to complete this. The other thing that we're going to do here is to submit your assignment. And submitting your assignment is using a program that's called Handin. So we're not using UMLearn for submitting your assignments. All of your assignments are going to be submitted from Aviary using a command line tool. What I would suggest that you do for this is, I'm going to show a demonstration of this a little bit later, but you can create a README file. A README file is like a description of your code. I put an example here of what I would put in a README to describe my code, and then the actual stuff that I've got. And then at the very bottom of this assignment document, I've got the command that you would need to run to actually turn in your work. I will demonstrate this a little bit later, but you should be able to do assignment 0 effectively immediately if you want to try this. If you want me to give you any feedback about assignment 0, please feel free to let me know, but there's not really much for you to do other than hand something in. And then I can tell you, yeah, it's been handed in, but that's kind of the limit for assignment 0. Yeah?
Does the handing function like basically send it to your mailbox in Aviary?
Sort of. So the question is, does it send it to my mailbox in Aviary? It actually places it in a folder. So kind of, it puts it in a mailbox. It puts it into a folder that you have write permissions only for your own files. So you won't be able to see other people's files, even though everyone else's stuff is submitted there. All you can do is write to this folder, and that's what Handin does. Yeah. Okay. I'm going to go to assignment 1 now, because that's, I think, probably the one that people are thinking more about than assignment 0. Assignment 1 is for assessment in this course. I'm going to be straight with you. You can't do assignment 1 with the material that we've covered in this course right now. By the end of this week, you will be able to do assignment 1. I want to publish it now, and I want to tell you about it now because the revision period ends tomorrow. This is a very fast turnaround course, and I want to make sure that you can make an informed decision about if you feel like you need to drop the course before the revision period is over. I just want to make sure that you got information that you can make decisions about. So I'm going to describe this at a high level, and then I'm going to show you a little bit about using Handin and compiling stuff on the command line, compiling Java programs on the command line. And then we will move on to writing some C code. So this assignment is about bracket matching. Your job for this assignment is to take a Java program. I've written a Java program. Your job is going to be to take that Java program and translate it into C. That's the first part of the assignment. The second part of the assignment is going to be for you to do something novel for you, which is making this program read input from the command line. The problem that's being solved in this code is bracket matching. And bracket matching is kind of like what your text editor is doing. When you highlight a bracket, it can match the other one. That's a specific problem of this. Bracket matching here is just counting and making sure that the number of opening brackets and the number of closing brackets and where they are placed among each other, make sure that they are balanced. So if I open a parenthesis, there should be a closing parenthesis somewhere further down in this string that matches the one that I've got. I don't care where it is in this problem, I just want to know that it's there. Here are some examples. This one is an opening bracket or parenthesis followed immediately by a closing one, and then another opening one followed by immediately by a closing one. This is a balanced string of brackets. For each opening one, there is a corresponding closing one. This one is not balanced. It has the same number of opening brackets or parenthesis. It has the same number of closing brackets or parenthesis, but they're not matched up correctly. So we've got an opening one, a closing one, immediately followed by another closing one. And so this one is not balanced because there's an extra closing one before there's an opening one for it. This one here is balanced. There's a lot of brackets and parentheses in here, but they are all matched. If we go to these middle ones here, they are matched. This one is matched. These two are matched. These two are matched. And these two are matched. This is a problem that you can solve with recursion. This is a recursive approach to making sure that these brackets in the string are matched with each other. The learning outcomes that assignment 1 is assessing you on are build and execute programs from a command line environment. So these ones are going to be assessed kind of implicitly. Connect to a remote Unix server with SSH. You're going to have to be able to do that to hand in your assignment. So that's going to be how that one's assessed. Execute a program on the Unix command line is going to be assessed by a grader running your code, kind of to verify that you've also run your code. Compile a C or Java program on the command line. The grader is going to try to compile your code and make sure that it compiles. Write safe code in a programming language that makes it difficult to write safe code. This is stuff we're going to be talking about in the next couple of days. Pass data to functions with sufficient information to prevent crashes and use compiler warnings to help prevent errors. This one here, the way that this is going to be assessed is we're going to use that WAL flag when we compile your code, and you should also be doing this. And we're going to be checking to see if there are warnings printed out. When we compile your code, there should be no warnings printed out, and there's an assessment level based on whether there are or whether there are not warnings printed out. I want you to be able to apply good programming techniques to produce readable and modifiable code in a programming language that makes it easy to write unreadable code. This is related to those best practices documents that are, and the programming standards documents that are alongside this. And then I want you to be able to write code that takes advantage of its environment through redirecting of standard input and output for file I/O. So when we run your code for the second part of this assignment, we're going to be doing I/O redirection with standard input. Here's the description of the problem. So perfectly balanced.java is a Java program that checks to see if a string contains balanced brackets. I'm going to download this file. I'm going to open it. I'm going to make this a little bit bigger. Can't make this any bigger. That didn't help at all. I'm going to open this in Vim in just a second so that it will be much bigger for us. I didn't make this picture, by the way. I just thought it was funny. This is a Java program that has a bunch of stuff in it. I'm going to take a look at it in just a second. The main thing that I want you to look at is this note section, which you can do on your own time. And the other thing that I want you to look at is the assessment section. When I make assignments, I try to be fairly detailed with how you're going to be assessed on an assignment because I don't really want surprises. I don't want you to be surprised about how you're being assessed. This is the same information that the graders will be given when they are assessing your code. So they're not going to be given any different instructions about how to assess what you've got. This is everything that they're going to get. For question 1, there's a total of 20 points that you can earn. It's out of 20, but there are 21 points that you can earn in the program that you submit. I will, again, let you take a look at this on your own. If there are any questions that you have about these levels of assessment, please ask them on the course forum, and I will answer them for everyone. One thing that's not a learning outcome that's being used to assess is the level of completeness and correctness of output compared to the provided Java program. So your program should be effectively identical to the output of the Java program if you want to get full marks for the assignment submission. The other part of this is actually changing that code to take input on the command line as opposed to just having a bunch of hard-coded test cases, which is the state that it's in right now. So I like this picture a lot, so I very craftily photoshopped a keyboard on it. The basic idea here is that the program that you've got is you run it, and there's a bunch of stuff that gets printed out, and it just exits immediately. I want to be able to run your program and then type stuff in interactively and see whether or not things are working the way that they're supposed to work. And the idea here is that I want to be able to send input on the command line from a file that has a bunch of test cases within it. Part of this is going to be assessed in a similar way to part 1, but there's also going to be 5 test files. I will be publishing these on Monday next week. 5 test files, and then each of those files is going to be worth 1 point for a total of 5 points for that part of the assessment. The last part here is about submitting your assignment. This is identical to what's in assignment 0, although slight things have been changed to make it say assignment 1 instead of assignment 0. But this describes what you should be submitting and then how to use that, how to run the Handin command along with an example of a README file that you might submit with your code. Like I said, we can't do this yet in the context of this course, but I want to make sure that everyone has information before we get to the end of the revision period. Does anyone have any questions about the assignment before I move on with anything? Yeah.
We're going to get confirmation when you have
So the question is, are you going to get confirmation when you hand in the assignment? For assignment 0, if you want to try it, you can email me and I will tell you yes or no. But there's also a message that gets printed out when you run Handin, and I'll show you what that looks like in just a moment. Okay, So just to be clear, your feedback will come on UMLearn, but your submission will be on Handin. So you don't submit anything with UMLearn, but you'll get feedback on UMLearn about your assignment. Okay, so this kind of leads to the next part of what I want to talk about today, and that's taking one little last look at using the command line, really specifically for compiling programs on the command line. We've done this a bunch of times so far. We wrote our program with Vim for C, and we compiled it using that clang command. So the command that we're using here is clang, C-L-A-N-G, and then -WALL. WALL is I want to turn on warnings. This is W. And then all is I want all warnings to be applied. This is the name of the file that we're trying to compile. So it's a C program that we're trying to compile. The -O here says this is the name of the file that I want to be created once this has been compiled. And then running it is using this // syntax. So remember what I said about places in the file system. The dot means right here, right here. // says a file that's in this directory, this is its name, I would like you to run it, please. That's what that's saying. I've put this up here as kind of a reference so that you don't have to, like, if you want to know all this stuff, if you ever feel the need to figure this out at 1 a.m. in the morning, you don't have to watch me on a YouTube stream. You can just open this file and take a look at it. But that's the same thing that I've just said. But this kind of leaves us, where are we supposed to go with Java programs? Yes?
Always required, or is that just better practice?
So the question is the // always required? On Aviary with TC shell, it's not required. So you may have been able to find that you can just run the name of the program directly in the directory that you're in, but that's not universally true for all shells. So if you have a Windows subsystem for Linux on your machine, you can't just do the name of the command or the name of the file that you've done, but it does work that way on Aviary. Yeah. Okay. So how do we do this with Java? Your task here is basically, I want to take a Java program and I want to translate it to C, but I need to be able to see how it works on the command line, how that program runs on the command line. What did you do when you were working with Java? And the answer here is that in Visual Studio Code, you clicked this run button. And I'll fruitlessly click this image on my screen, and it's not going to do anything. But you click the run button, and then at the bottom of VS Code, the little terminal pops up, and it prints stuff out, or you can type stuff in, or whatever. But you click the run button. And a really long, complicated-looking string appears. A really long, complicated-looking string appears, and then your program starts running. But that's not going to be helping us when we're trying to run stuff on Aviary. I want to be able to transfer something to Aviary and to run it. To compile things on the command line with Java, you use two programs. One is called Java C, and the other one is called Java. Did anyone use Dr. Java? A couple of people are just like, oh my God, no, I don't even want to remember that. With Dr. Java, you had to click two buttons. You had to click the compile button, and then you click the run button. With VS Code, you just click the run button, which makes a lot more sense to me. With Java on the command line, we need to use Java C to compile our Java code, and then Java to start the JVM and run our code. So what I would like to do now is to take a look at that. I'm going to pop open a new terminal here. So again, I am using this terminal multiplexer called tmux. If you want to use it, awesome. I can help you get it set up if you want to use it. If you don't want to use it and you just want to have different terminals, also cool. But just so you know what I'm doing, I'm using tmux in just one terminal window to do this stuff. So in my downloads folder, I've got a program now that's called perfectlybalanced.java. I want to start by transferring this file to Aviary. I'm going to say scp downloads perfectlybalanced .java. And then again with transferring to Aviary, it's the same kind of connection string as a target as you use with SSH. So your UMNet ID at aviary.cs.umanitoba.ca, and then a colon at the end. The colon there says, I want to send this to a remote host. If I don't have the colon, it's just going to copy the file to a new file name that's called that, very helpfully. When I do this, you might have noticed that it didn't ask me for a password. So another super quick diversion, super quick diversion. I've posted a post on the discussion forum that you can use to do this on your own machine, but I'm using something called public key authentication as opposed to password-based authentication. If you've got a machine in front of you right now, you can run this program called SSH Keygen. I'm not going to run that, so just SSH Keygen. That will make a public and private key pair for your personal machine. And then I've put a little snippet that you can use on a Windows or Mac OS machine. This is on the discussion forum on the course webpage. Course material. Setting up public key authentication with SSH. There's something that you can kind of just copy and paste and edit for yourself. If you're using a Linux machine, this is automated with a program called SSH Copy ID, and then you put the name of the host in your username, so you don't have to do this like piping thing. But you're going to be typing in your password so many times this term, and this will just save you a lot of time and effort once you get that set up. When you do SSH Copy ID, or when you do that long string, you will have to type in your password once. But after you do that, it should be set up and it should just work. So I'm going to SSH to Aviary now. And I've got perfectly balanced.java. I'm going to start making a directory structure here. So make dir to make directories. I'm going to make a directory called comp2160. I'm going to change into comp2160. I'm using my tab key here to finish. I'm going to make a directory called assignment1. I'm going to change into that directory. And then I'm going to move perfectly balanced. So perfectly balanced. What's the name of the symbol that we use to refer to our home directory? Tilde. So move from my home directory, perfectly balanced. Again, I'm hitting that tab key to autocomplete for me. I want to move it here. I want to compile this code. To compile code in Java, you use the javac command. So I'm going to say javac. I'm going to tab perfectly balanced.java. And I'm going to list the contents of this directory. And now there's two files here. There's a .class file and a .java file. The .java file is the one that we transferred. This is the one that we wrote. The .class file is the compiled version of our Java code. To run this now, we run Java, just Java, and then the name of the class. So I'm going to hit tab, but this is a place where tab hurts me more than it helps. Actually, it helps a lot. But I need to delete the period. So those two files have the same beginning up to the period, and so that's where tab gets us to. But when I run a program on the command line with Java, I just put the name of the class that's in that file. I don't put the .class extension here. So I'm going to hit enter. And what this does now, I've compiled it, I've run it. This code is going through and it's running a series of test cases. I'm going to give you a second to catch up if you're following along. Okay, I'm going to open this file up. So I'm going to edit perfectly balanced.java. perfectly balanced.java. Is that big enough at the back? Can you see that okay? Yes? Okay, thank you. Is that a no? Okay, I can make it a little bit bigger. Tell me when to stop. That's good? Okay. So perfectly balanced.java is a class and a main method and a bunch of other stuff that will do this string checking for balanced brackets. Java has a multi-line string feature. Maybe you've seen this, maybe you haven't, but these three quotes beside each other is like saying that what follows is going to be multi-line string, so you don't have to put extra pluses and stuff in there. It just lets you put all this in. So that entire string right here, this entire string right here, is all inside that variable called perfect. This is my attempt, like my really bad attempt at ASCII art, by the way. Each of these is calling a method below that's called test balance. I'm going to scroll down. Test balance is a method that calls a method called isBalanced. And isBalanced is the actual method that tests to see if a string contains balanced parentheses. This is a recursive algorithm, and it's at certain points that we are recursing, and it's usually from the context of, I've looked at the very first character of the string, now I need to recurse on the rest of the string. This uses a bunch of string manipulation, which we will get to, This uses some stuff in Java that you have probably never seen before. These are assertions. These are related to something that we're going to talk about later in the course called design by contract. You can just copy what I've got here in terms of what these things say. So the thing that I'm passing in should not be null, and the value of this number should be greater than or equal to 0. This test method here is called a test harness. This is so that I can call isBalanced a bunch of times with an input and also with what I expect the output to be. We will talk about testing later. This is provided to you right now to use, but it's a preview of what we're going to be doing later in the course independently. In our main method here, we've got a bunch of test cases. So a bunch of inputs and then a Boolean that says true or false. This is a balanced thing. I know this when I've written it because I personally wrote all of those strings down. I know that yes, this is balanced. IsBalanced should return true. I know that this is not a balanced string. IsBalanced should return false. That's all this method is doing, is just calling that and checking to see is it true or false based on what I told it to be. In terms of you writing this assignment, you can very safely, I'm giving you explicit permission here to copy and paste the main method, the middle part of it. The main function that you write obviously has to be a little bit different in C, but this part here, for the most part, you can just use wholesale without having to make too many modifications to it as you're going through and translating your code. So that gets us to the point now of being able to compile and run Java code on the command line. The last thing that I want to do here is I want to show you how to use Handin. So I've changed directory out of my assignment 1 folder. So I've got comp 2160 in my home directory. I've got assignment 1 within that. To use Handin, Handin is a program that takes 3 arguments. So we run Handin. This is no /. This is just a command that's available for everyone to use on the system from anywhere. The course number, so 2160, and then the name of the folder that I want to submit. So the name of the folder that I want to submit is assignment 1. When you do Handin, you can, if you want, put your username and stuff as the name of your folder, But when you do Handin, what I get on the end is a file that's named with your UMNet ID, so I know who it came from. The README file that you put into your folder should also contain some identifying information, what your name and student number is, just to help the graders when they get your work. But ultimately, we will have this information from Handin itself. So if I do Handin 2160, sorry, the next thing is assignment 1. This is the name of the assignment. I'm telling you this is the string to use. And then the last thing is the folder that I want to submit. When I do this, Handin will print out something. So this is to answer your question here. It says Handin was successful. If Handin was successful, Handin was successful. It worked. If you get anything else out, so there can be messages printed out if you're handing in something late, it will reject your submission. If I have misconfigured something, it will print out like error, permission denied sort of thing. It should work. Did you try it? Did anyone try it just now? Someone try it right now, live. Folder, anything. Good, it works. Awesome, it works. That would be super embarrassing for me if it didn't work, wouldn't it? Not really, I guess. I would just fix it, and then it wouldn't be a big deal. Okay, so that's how you use Handin. That's how we compile Java programs in the command line. That's how we run Java programs in the command line. We doing okay? All right. Yes, please. That's a good question. So I'm going to repeat your question. Can you hand in multiple times? And the answer is yes. The answer is also, please hand in often. Don't wait until the very last second to hand in everything. When you complete part of assignment 1, hand it in. When you complete a little bit more of assignment 1, hand it in. When you complete just a little bit more of assignment 1, hand it in. Just keep handing in. That means that you will have something submitted. You'll have something submitted no matter what state it's in. The very last thing that you submit, so if I do this command again, it tells me there that a previous submission was there. Whatever I handed in before gets deleted, and then what I've just put here will be copied into that hand-in folder. So you can hand in as many times as you want, and it will just delete previous submissions. Yeah?
Is it possible to pull from that repo?
The question is it possible to pull back from hand-in? I can. So if you are in a bad state, I can email you back your assignment, but that's the best way to get things out of hand-in. Otherwise, the answer is kind of no. Any other questions? Okay, awesome. So, I would like now to start writing some C. I would like to do this by translating a simple program that's written in Java to C. The goal that I have when I'm doing this translation is to compare the languages while I'm doing the translation. The program that I've got, that I'm going to show you in just a second, will read from standard input. We didn't talk much about standard input yet. We will talk about it more next week. But if you're familiar with Java, which you all are, and you're all familiar with scanner, yes, okay. You're all familiar with using system.in for scanner, okay. That is standard input, where I can type stuff in with my keyboard. That's all we need to know about it right now. I run the program, and I can type stuff in with my keyboard, and that gets put into a variable some way or somehow. I want to read from standard input. I want to write to standard output, system.out.println, prints to standard output. What we see on our screen for now, for the purposes of what we're doing, is standard output. I want to declare some variables. This is a really basic thing to do in a programming language, but I want to see how the two of them differ from each other, if at all. And I want to have a loop. Again, kind of a basic structure, but I want to be able to see this structure in both cases. Please type along. If you have a machine in front of you, whether you can connect to Aviary or not, please follow along with what I'm doing right now, if for nothing else than to get yourself comfortable with typing code in C, to break the Java off your fingers and to start getting some C on your fingers. On today's section of the web page, there is a file under Lectures, Week 1, Lecture 3, that's called toLower.java. You don't have to have this on your machine. I will have it displayed on the screen so you can see it, but it's here for you to download if you want. This is the program that we're going to be translating. I've got it here. The very first thing that I do when I am translating a program from one programming language to another programming language is to read the program that I am translating, to try and figure out what it does before I even run it. This is a program that has things that came before Scanner, that came before Scanner. So buffered input readers, input stream readers. These are things that you may have used with file stuff in Comp 1020. You can also use it with standard input. This program has a try block, and the try block is here because of input stream reader and buffered reader. And I'm going to go all the way to the end of the try block here. And what it's catching is an IO exception. This is an exception that can be thrown by one of those two classes that are being used at the very top of this main method. What this does is we have declared an integer that's called letter. Letter is assigned to reading from standard input. And there's a comment that someone helpfully wrote for everyone to read. And it says that the read method returns a single byte of input, and it returns -1 when there's no more input to read. This is an event-based thing, so I am using a while loop. The event here is that there is no more input for me to read. When I'm reading lines of a file, the event is there are no more lines left in that file. I won't know in advance how many lines there are, so I can't really use a for loop, so I kind of must use a while loop here. This is an event that I'm working on. The next thing that I see here is system.out.print character.toLowercase. So I know what this does already, system.out.print. I can infer what this does based on its name, character.toLowercase. Even though letter is an integer, I can cast it to a character because, at least on my keyboard, all I've really got are ASCII characters. So this is just Latin, English alphabet letters that I can type in on my keyboard. This will take a single character, convert it to lowercase, and print it out, and then read the next character from standard input. So this does one single character at a time. It converts it to lowercase, and then it prints it out. At the end, we close the standard input stream. And then at the very bottom of this, we just kind of fall off the end and the program exits. So let's try this out. So I'm in this folder that's called Comp 2160. I have toLower.java, Java C, toLower.java, Java toLower, just toLower, not the .class extension. And now it's just stuck here. It's waiting. It's waiting for me to type something in. So if I type in hello comp 2160, it reads in one character at a time. It's kind of looks like it's done an entire line, but it's reading one single character at a time, printing it out, getting the next input, converting it to lowercase, printing it out, getting the next input, converting it to lowercase, printing it out. To exit this, to cause that event to happen here, I want to force this read method to return -1. What I type on my keyboard is Control D. So if you ever see anywhere written this, Hat D, that means Control D on your keyboard. Yeah. Control C and Control D do different things. Feel free to ignore me for a second. Control C sends a signal to the process to kill it. This is a way that the shell is kind of saying, I want you to stop what you're doing right now. And I'm not even going to give you a chance to stop what you're doing because I'm going to say, operating system, please terminate this process. Control D flushes the input buffer. Flushing the input buffer with nothing on the line says, I've sent nothing to input. Read returns something like -1 or 0, and then the loop exits, and then the rest of the program finishes. So Control D says, there's no more input, just finish processing. I'm sending you the event that I want you to terminate on. Control C says, operating system, help me please, and kill this process. Yeah. Okay. So I want to translate this to C. So I'm going to start a new C program. I'm going to call it toLower.c. We've seen this a couple of times, and I'm going to politely ask you to chant with me. And if it's just me chanting by myself, that's totally fine. Number sign includes stdio.h. Number sign includes stdlib.h. And now I'm going to add one more thing. I'm going to say number include ctype.h. I am including ctype.h because I have a little bit of information that you don't. The little bit of information that I have that you don't is that there's a function that I can call called toLower. I'm going to pop this open, and I'm going to say man3 toLower. The manual pages can be used to get information about commands. The manual pages can also be used to get information about functions that we can use. This would be a good place for you to do something like ask ChatGPT, what function can I use to translate from uppercase to lowercase in C? That would be a reasonable question to ask ChatGPT. Then you can come back and get more information from the manual pages. Man3 toLower says, I'd like to look at section 3 of the manual pages, which is always going to be code. It's always going to be functions that we can call in a C program. This gives me an example of what I need to include. So it's ctype.h, and then there's two functions that I can call here. And they both take and return integers. So this is toLower. Okay to ask ChatGPT, what function can I use in C to translate from uppercase to lowercase? That would be an okay question to ask ChatGPT. I need to have a main function. Okay, so please chant along with me again. Int main. Oh, I did this different both times, so it's super okay that you don't remember. This time I'm going to put void. I am not expecting arguments to be passed. So again, arguments here mean things like I'm not doing rm-r. I'm not doing dash anything with the program that I'm writing. I'm just going to run it. So int main void, I want no arguments to be passed to this thing. I'm going to go up here. This is now technically, functionally a little bit different than the Java program in that the Java program can technically accept arguments on the command line when we run it. I could say Java toLower but upper. I guess, if I wanted to, I could do that, and it would get put into that string array, but it's not actually going to do anything because in the main method that we've got, we never look at the args array. So functionally, they're slightly different, but for the purposes of what we're doing, that's fine. We've got 3 variables that are declared here. We've got int letter. I will declare that. In C, most of the types that you use in Java are the same. Most of the types. Int, float, double, long, char are all the same. We've got a try block. C does not have exceptions. There is no concept of try catch. I cannot do error handling in the same way in Java. I can't do it in C the same way that I can do it in Java. There is error handling in C, but it's not with try-catch blocks. So I will skip the try part. The next 2 lines in my Java program are input file is input stream reader and standard in is buffered reader. There's several readers in Java. C does not have readers. C doesn't have buffered input reader. So I can't really translate that part. C has a function that's called getChar. I'm going to use my manual page again, getChar, man3 getChar. Section 3 of the manual pages is functions that I can call in the Linux Programmer's Manual. This actually refers to a bunch of different input functions that we can call. The synopsis here says include stdio. We've done that already, so we don't need to add anything for this. A reasonable question here for ChatGPT would be, how do I get a single character of input in C? How do I get 1 single character of input in C? getChar, I'm going to scroll down here, returns an integer, and it takes no arguments, void. I do not pass anything to it. So I'm going to say here, letter, this is the name of the variable that I declared, is equal to getChar. No arguments. I cannot pass anything to this. The thing that I've translated here right now is effectively letter equals stdin.read. So I'm going to put a comment just above this. This is letter equals stdin.read in Java. This is priming my loop. I get something as input. The next thing I'm going to do here is to begin the structure of my loop. C, like Java and like Python and like every procedural programming language, has loops. It's got a loop. It's got a while loop. The syntax for a while loop in C is while letter greater than 0. The difference between these is kind of beneath the covers. It's beneath the surface. In Java, while takes a Boolean expression. It's literally a Boolean type. So you could say Boolean whatever equals that expression. This is going to be something that evaluates to the literal true or the literal false. In C, this is an integer. This expression evaluates to 1 or 0. 1 being true, 0 being false. So I'm going to change this just slightly. I'm going to say while letter. For now, I'm going to leave it as greater than 0. I don't want to make this too different. There's two ways that we can do the next part. So I'm getting the character here, and now I'm printing output. I'm calling toLower. So I want to quickly open up my manual page for toLower again. toLower takes an int and it returns an int. Okay, so that's good. That's kind of what I want. To print something, I can use one of two functions. One of them, so system.out.print in Java, I can either use in C either putchar, so we've got getchar, read from standard input, one single character, putchar, put one single character, two standard outputs, or printf. I'm going to prefer to use printf here over putchar. Putchar would be a more direct translation, but I want to use printf for the sake of using printf right now. So I'm going to say printf. I'm going to quit my manual page with Q here. I'm going to say man3 printf. Printf comes from stdio.h. That's where the header is defined, or that's where the signature of this function is defined. I'm going to scroll way, way down here to format of the format string. The first argument to printf is a string. Strings in C are double quotes, just like they are in Java. Characters in C are single quotes, just like they are in Java. The format string is a string that describes what should be printed and how it should be printed. A format string here is, it starts with a %, and the thing that I want to print out here is a character, so %C. If we scroll further down here, there's flag characters. This is for numbers of output. There's field width. This is for everything. There's precision for floating point numbers, length modifiers for numbers, and then just past this are the conversion specifiers. So these are all the things that say I want this to be a number, or I want it to be a letter, or I want it to be a string. %C is for a string, or for a character. What I want printf to print out here, whoops, is toLower. So I want to try to keep this as close as possible. Letter. And then the very last part of this is letter is equal to getchar, the same thing that I did to prime the loop before. I'm going to quit my manual page here, and I'm going to hit Control D to close this part of my terminal so that we can see the whole thing. So this is 33 lines long, mainly because I put a bunch of comments in here, where the Java program is 47 lines long, and it has many fewer comments. There are no exceptions. I've got some type declarations. I've got a loop structure. We recognize, or we can hear from me saying that that expression in the loop structure isn't Boolean necessarily, but rather evaluates to an integer that's 1 or 0. The last part of this that I have to have is return exit success. And remember that we get that from stdlib.h. So I'm going to write this. So escape in vim :w. I'm going to go back to this other terminal with my Java program. I'm going to quit, so :q in command mode. I'm going to list the contents of this directory. I have toLower.c. I'm going to compile this. Please chant along with me. Clang -w all toLower.c dash o toLower. Thank you for all of those half-hearted chants. Yes, good. It compiled successfully. Excellent. And I will run toLower, and it will sit here waiting for me to type input. Hello, comp 2160. It works. I will hit Control D on my keyboard to tell it to stop. Okay. So I will put this file up on the course webpage alongside toLower.java. I'm going to quickly go back to my slides in the last dying seconds of class here. We're going to look at a more formal view of the differences between these two languages. But what you should be able to do at this point is compile a C and a Java program on the command line. You should be able to write multiple different simple C programs now. You have some idea of how to get input from standard input. You have some idea of how to print to standard output. You can write hello world. You can write a toLower program. You could do some slightly more complex things than that. You should begin to be able to recognize potentially risky programming techniques and how they differ in high-level programming languages, really specifically in the context of Java had this cool exception thing. The C program we wrote did not have any exception handling at all. That's it for today. I will see you all tomorrow. If you wanted one of these cheat sheets, I did print more out. If you didn't get one yesterday and you want to get one, please come and grab it. I'll see you all tomorrow. Bye, everyone.